And we're back.
And we're back. All right. As promised, looking at Cessna 150 POH. So it stands for Pilot Operating Handbook. All right. So at 2,000 feet, I choose my horsepower setting. If I'm climbing, I want up here. But let's say I'm in cruise. I want 70, 62%. And so what? We'll say 62%. I want 65. They don't have that. So I'm going to power back to 2,400. But if I climb up here to 8,000 feet, how many hours would it take to get to there? I don't know. And I want 65% power. I'm at 2,600. I don't know. This is wishful thinking. But a wide open throttle, pretty much, what percent horsepower would you get?
70.
Yeah, basically just 70. And why you can't, I mean, it probably won't even get 2,700 up here is probably why it's that way. So, all right, as opposed to, it's a little different with the constant speed. This is for my aircraft. So I got 6,000, 8,000, 10,000. So let's just say, what's the lowest tab on here? 2,000 feet. This had it on the last chart too. I didn't show you. So you got your standard temperature above and below, below and above. So if you're at 11 degrees Celsius, follow this one. If you're at 31, you're going to follow that one. If you're -9, you're going to get that one. But let's just take a look at standard temperature. I'm going to cruise at 65% horsepower as on a standard day. What can I do? Well, I got all kinds of choices. I can go 2,400 RPM, which is red line. I can do 23, I can do 22, I can do 21. You choose. You get to pick. And so you pick. Which one you want to pick?
22.
And that's how it works. I think today I'll do 22.
Pick on your fuel rate.
If I want 65% power, then I'm going to set my manifold pressure at 21 inches. Well, sorry, I already defaulted to this. It's just easier to do that. Or I could have said, no, I want 65% power, and I'm going to go 2,400. Well, then I'll go 20 inches instead of 21. Or if I want 2,100 RPM at 65, then I'll go 22 inches of manifold pressure. And is it about the same fuel burn? Let me see, this one is
Gallons per hour.
128 versus about 128 versus about 128. So you're going to get the same speed. Pick any one, you're going to get about the same speed. And fuel burn, 11.5, 11.7. Well, definitely go that one then.
10.9.
Somewhere in here. Yeah. So it's about the same fuel burn. Follow? Okay, so my point being that as you go up in altitude, to compensate for a loss of density in the air, you have to either increase your RPM or increase your manifold pressure. Hopefully I tied that in okay. Questions on that? Like, I don't know what you said, so I wouldn't even know what to ask. All right. A rich mixture burns slower than best power. I think that's where I went off. I went off on this whole best power thing. Oh, but we also have to talk about the fact that the speed of the burn changes. So if you have a rich mixture, it is going to burn slower than best power. Right. Uh-oh. I see a lump. There it is. All right, let's see. Rich mixture. Lean mixture. Lean mixture as much as 18 to 1. So that's 18 parts air to 1 part fuel. Which would be 0.055, as opposed to the rich, which was, did I write that one down? What's that? That's 0.125, actually. So So it's 1 divided by 8, or 1/8. So I don't know if that works better for you. 8 to 1 is 0.125. That's a higher number here. So that's rich. The lower it gets right here, the leaner it's going to get. Maybe. I've never worked it that way. Okay, a lean mixture. We'll say that's 1. We'll say that's 2. Lean mixtures burn very slow as compared to best mixture. So which mixture burns the slowest? Lean. Burn very slow. There's a Q&A question. It says excessively lean mixtures can burn so slow that the fuel is still burning when the intake valve opens. Q&A. Wait a minute. Oh, I think it's just the answer. I think there's something about what mixture could cause a backfire. Remember, a backfire is through the carburetor, and an afterfire is out the exhaust. It's the difference between a burp and a fart. So a burp is a backfire. It goes backwards. Oops. Afterfire goes the right way. All right, so yeah, there's a question about that. Which mixture? I don't know, something about that. But there's in your Q&As, the theory is, and I don't necessarily buy into this, but okay, fine, that an excessively lean mixture, I'm just going to write it and we'll say, well, because it works you. Excessively lean mixture or mixtures can burn so slow that the fuel is still burning when intake valve opens.
That's a backfire.
Yeah. All right, that's one theory. Now, if you follow that through, intake, compression, ignition, fuel starts burning. Power, fuel's burning. Exhaust, fuel's burning. Comes down for intake. Oh, now it's still burning and lit off the... It's kind of asking a lot. It's kind of asking a lot.
Well, valve overlap, right?
Not all aircraft have valve overlap. Lycomings don't. So, let me see. Yeah, this causes fuel and burn causes back. Yeah, so that would then cause the fuel coming from the carburetor to get lit off, and then it backfires. And not likely, but it is known to happen in radials because they move pretty slow. But anyway, there you go. It's a Q&A thing. Kind of not sure about that one. Okay. Here we go, burn speeds. Here is a graph showing this. So, best power mixture. So we get our most power, right? Because you can look at what's the curve showing me?
Best power.
Flame propagation rate. So this is how fast the flame is going to move. So we said a lean mixture burns the slowest. So here we are at best power. We can go either side of best power, and the speed of the flame is going to be roughly the same based on this chart. Almost looks like it increases just a little bit right there, but I think it's supposed to be flat. And so if we lean it out, it goes slower and slower and slower and slower and slower and dies off right here. But if we go rich, it goes here to here to here, and then if you go past there, what happens? Engine stops.
Yeah.
So this is as slow as you can get before the engine stops. Over here, this is as slow as you can get before the engine stops. So which one is the slowest? Lean. Let me see. A little bit leaner and a little bit richer. Or the...
Best mixture.
No, if I'm at best mixture, that's that point right there. But if I make it a little bit richer, what happens?
Power drops.
Power drops.
Well, this isn't a power curve, it's a time curve.
Oh, the flame, yeah, the flame length.
A little bit richer, what happens?
Slower.
Yeah, burns slower.
It's the same. A little bit leaner, it's the
Same.
same. So a little bit each side is pretty much the same.
Same
Yeah.
pressure.
Okay? But, I'll write that. Let me see. So just bringing the valve opens. Let me see. Burn speeds. We got that. A, B, burn speeds. Let's see. We had figure 6-16 shows that both rich and lean mixtures burn slower than best power. But lean has the ability to burn the slowest. A little bit rich or a little bit lean of best power. Burn at the same speed. Why would we care about burn speeds at all? You're like, right now I don't. So I don't. I'm going to just move my little 2 out here because it's like I'm over here. So here's 1, here's 2. It's like for those people that say, hey, you got to go big or go home. It's like, I did not know going home was an option. I will see you later. Thanks for that. And that's really annoying when I slam that down on the table and you're listening to the recording, huh? Yeah.
You should have my water bottle.
And if I'm not, then it's... all right. Burn speed is important. Burn speed is important. Is important due to where? Due to where the peak pressure point, that's the PPP, of combustion happens. So this is all, like, remember I said, like, when we started this whole thing, like, failure to kind of understand this really just leaves you at a loss for everything that happens in a carburetor. So hopefully you're kind of following this. And not only that, there's just so much information, so much misinformation. Pilots, mechanics alike just do not understand what's happening with this stuff, and so they start spewing things that just aren't true. So it's my hope that you will at least understand some of this stuff, or if nothing else, understand that you don't understand, so you'll, when they ask your opinion, be like, yeah, that's a lot of information I don't want to share with you. Like, I know, but I don't want to tell you. All right, peak pressure point. That's when the maximum amount of pressure happens in the cylinder. Where do you suppose the peak pressure point should happen? So the triple P, the PPP, or I guess I could go P to the third. Does that work? I don't know. Should happen. Where? Where do you suppose?
Best power.
In the timing sequence.
A little passing by, right?
Top dead center.
After
Power
top,
stroke. Top dead center.
Yeah, top dead center.
Of compression.
After top dead center.
Right.
Right before top dead center. You pretty much have A, B, or C. Oh, I guess D. A, before top dead center. Before top dead center, B, top dead center, C, after top dead center, or D, all of the above?
That's a test question. Huh?
After.
That's probably not. I made it up.
Sounds like a test question.
It does. It was supposed to sound like a test question, but it's not at the moment. All right, if the peak pressure, the maximum amount of pressure happens in the cylinder while the piston's coming up, what's the piston going to want to do?
Go down. Go back.
Go back down. If it happens at the top dead center, what's it want to do?
Go with the lean.
Kind of locked this way.
It's gonna push on the shaft.
Yeah. Okay. If it happens after top dead center, it wants to
Yeah. Go around.
make the crankshaft go. So I say we could say it should happen
After.
after top dead center. Okay. So at high power settings, a rich mixture will move, or lean also, but for some reason I'm talking about rich, will move, the rich mixture will move the P3 to after top dead center. Okay, why does that matter? Okay, why did I say rich mixture, not a rich or lean? Because it's true for lean, but I'm talking about max power right now.
Takeoff.
So we're at takeoff. Well, if rich puts it on the peak pressure point on the other side, and lean also puts it on the after side, then why would it matter if I'm rich or lean, or does it matter?
Cool.
Well, it matters a lot.
Mm-hmm.
Because remember the 8087 fuel? If nothing else, we had the red fuel, it's 8087. What did the 80 stand for?
Low.
Lean.
Lean.
Lean mixture.
Yeah.
What did the 87 stand for? Rich mixture. So the 100 low lead, we said it's like 100, 130 really. So would I rather have on takeoff with a high power setting, would I rather have the 100 octane or the 130 octane? And I think so, because what happens if I have a lower octane?
Yeah, detonation.
Detonation. Okay, so that's one thing. Two, we're going to look at a power curve. And when you look at a power curve, the power curve looks a lot. So I can just get one real quick. There we go. Power curve. Let me see. Average EDT, average cylinder head to brake spread. Cylinder head. Let me see if I get the right one going here. There we go. You see this graph right here? Okay. This is lean. That's your power curve. So here we are, best power, somewhere in here.
Mm-hmm.
Let's say somewhere in here. And I go rich. What happens to my best power is I go rich.
Slowly.
Slightly.
Goes down slightly.
Yeah.
What happens when I go lean?
Very low.
Yeah, you want to be with power here on takeoff in a mountain, or do you want to be here?
Up there.
Okay, so you want to be over on that side. So definitely takeoff, high power settings. We want rich because of detonation protection and more power. All right. And we want, oh, okay. And then why don't I just use best power?
Fuel economies.
We're cheap, but we're not that cheap. Temperature,
Yeah.
cooling,
Cooling,
all those things. But more importantly, what are we talking about here?
yeah. Oh, pressure. Pressure.
Peak pressure point, where I want the peak pressure point.
After top dead.
Later in the thing. So yeah, I'm giving up a little power. I really am. So we go to take off. I'm going to take off tonight, go home, and I'm going to have a rich mixture. My car, you're going to learn, carburetors are set up to automatically do this. So there's best power, and the carburetor's going, okay, you want best power? Great. Oh, you just went full throttle? No, we're dumping more gas in. So what happened to my best power?
Right.
It's gone. I'm not getting best power.
Yeah.
I'm getting an excessively rich mixture. And I can really see that on my engine gauges, for sure, my plane. But it's moving it on that way. Why? Going to keep the engine cooler. Not that, I was taught that the gas cools the engine. I don't know about that. We'll talk about that in depth, and you'll see. Well, I suppose, but it has more to do with some other things. Let's see. We're going to move the peak pressure point back, so we're not going to get detonation. We're going to get detonation on the back side of that. Piston's coming up, peak pressure point before top dead center. Oh, I think we're going to get some detonation on that. That'd be bad. So we're going to do it after. All right, follow me on that one?
Yep.
All right. So where peak pressure point, P3, happens, will have an effect on cylinder pressure, obviously, which has to do with detonation and temperatures. And we're talking about temps now. So that means we're kind of like out of that little section right there. So you follow the peak pressure point. We've got that, we have rich mixtures, we have lean mixtures, we have a best power mixture. Okay, so far? All right. For many, many years, it was just hammered down pilots. When I went to Lycoming school, I thought I was going to watch two old guys come to blows about running leaner of best power versus richer of best power. So I'm going to talk to you all about that stuff. And
Who's your money on?
what's that?
Who's your money on?
Lee.
Yeah, it was on the wiry little guy, man. So yeah, they argued. It was it got ugly.
Damn.
Most of your factory literature wants you to stay on the rich side of stuff. All the newer literature actually goes way back to World War II, actually, where they're running lean. I don't want to get into that. We'll get to it. So at the right time. Let me see. So we'll talk about temperatures. And this is like similar to the one I have in my airplane. So you can monitor on some aircraft all of your exhaust gas temperatures and all of your cylinder head temperatures. And like I said, you can see a very rapid change in temperatures on your exhaust gas temperature, EGT, exhaust gas temperature, based upon how rich or lean you are. So when I go to take off, I will be running EGTs probably below 1,000 degrees, 800-900 degrees on takeoff and climb out. But as soon as I reach 1,500 and lean it out, I'll pull back on the mixture. I'll start leaning it. And I'm leaning it. Now I'm overly rich. I'm going to what?
P.
Best power. As I get close to best power, I'm going to see 1,410 on mine. So you see a real rapid change in that exhaust gas temperature. And then that will eventually have an effect on your cylinder head temperature, which we'll talk about coming up. But for now, we'll just talk about temperatures. So we know all these temperatures I'm going to talk about. Temperatures. All right, what are we going to monitor here?
Cylinder.
Cylinder. Cylinder head temp, or CHT, cylinder head temp. All right, so unlike cars, what do you monitor for temperature in your car? Nothing. You just got an idiot light. You didn't even know anything.
Transmission oil.
Huh?
Oil temperature.
Transmission oil.
Very few things have a tranny temp. So you have water temperature.
Water temperature.
Yeah, well,
Your coolant temp.
my car only has a coolant light.
Coolant light.
Cold or hot, that's it.
Okay. So, all right. So, unlike cars, aircraft, or at least our piston aircraft, whatever. Unlike cars, aircraft need the CHT managed and monitored closely. Well, that's not really a true statement. Tell us about your CHT and your 150.
Yeah.
You
Doesn't
say-
have one.
You say, yeah.
Yeah, doesn't have one. Not an option.
It runs hot.
They don't want you. You don't need to know. So, to say that you have to have a CHT and you have to monitor it, it's false. A lot of aircraft don't have them. What about EGT? Nope. You don't need to know.
It's hot.
So I can say aircraft. Some aircraft use the CHT gauge. Mine came out of the factory with one cylinder head temp probe. That would yours have 1. And stick it right in the middle cylinder. Number 4, I believe, is what mine was. Middle right side. And that's it. So it's kind of flying blind. Imagine a car that didn't have a computer, didn't have an idiot light, and had no way to monitor your coolant temp. It was just like, well,
Drive until it dies.
that's it.
Oh, a lot of tech guys.
Yeah, well, imagine that in an aircraft. It's
You see,
Yeah.
Scheduled landing.
you from the other side.
Does that information help you? Does it improve your flight?
Yeah,
It does? Okay.
yeah. To a point.
Yeah, what if you just engineered the engine so you only needed one temperature to warn you and just went and flew on your way?
I'll be on your pedestal.
Lots of people do it.
Okay.
Lots of people do it.
Well, when I took off at Harris Ranch, and when mine was after firing, what I noticed first was actually my CHTs and EGTs.
Yeah.
That's what, before the engine started running rough, that's what I noticed. And then it started running rough, and I turned around and landed.
Okay.
But, so that, I mean, to me, it's a lifesaver. But
Yeah, when I flew my aircraft for the first few months, year before I had a full engine monitor, I was terrified to lean it. It's like I don't know what I'm doing. I only know 1 cylinder head temp. I only know 1 exhaust gas temp. I don't know what the other 5 are doing. Could I be ruining my engine? Could I not be? So I flew around with it quite rich. So flying around with it rich means now I'm dumping a bunch of lead in the engine. I'm getting lead fouling, lead buildup in the cylinders. It's never going to come out. On and on and on. So now that I have all this stuff, I'm a super aggressive leaner. I mean, seriously, I level off at 1,500 feet. I'm yanking that red knob all the way back until it starts to run rough and pushing it back in.
What's the difference between that and not having it? You could have done that before.
Couldn't done it before. Yeah, I could have.
Risk overheating everything. Though, and not
I could. So that's why I
but he
said
did
to a
the same
point.
thing he's-
To a point.
But he-
Now, if I got in an aircraft that's exactly like mine, and well, now that I have the gauges, I can correlate the feeling in the gauges. So you can. So, okay, believe it or not, the POH, Pilot Operating Handbook, like for my airplane, how do you lean the aircraft? Pull the red knob back out until it starts to run rough. Then push it in until it smooths out. Well, there's a lot of leaning procedures, but one of the leaning procedures is pull the red knob out and watch your EGTs until they peak. So as you pull it, they're going to get hotter and hotter and hotter and hotter. Then you're going to get lean. You're going to get the best power. Then you get lean. It's going to start going down, down, down. Okay? So pull it back until it reaches peak. And then this is where then you can push it in like 25 degrees until it cools back down 25 degrees. So that's called 25 degrees rigid peak. We'll cover this again. Well, guess what? If I pull that knob out till I can feel it in my butt and push it in until it gets smooth, I just did the same thing.
Yeah.
But I didn't know that until I had all the instrumentation to go, okay, that's good. They were right. So we have the CHT gauge.
And my IO360, pull it out until it's a little rough and then bring it back in. I'm doing the same thing.
You have an O360.
IO.
IO360.
Yeah.
The big difference between your engine and mine is yours is a fuel injected,
Yeah.
which has really good fuel distribution.
Okay.
My aircraft is known as the worst fuel distribution of any aircraft ever made. So people talk about running rich at peak and lean at peak. I do it all. I run my middles at peak. I run the front ones lean at peak and the rear ones rich at peak. So I'm a test bed for everybody. All right, so a CHT. Did we talk about this last class? Where should CHTs be?
Yeah, cylinder.
How to cylinder?
All right, ice. Now, what's temperature?
Oh,
Less than
400. Less than 400?
I like to say less than 400 degrees. That's my personal thing. The 182Q POH says 435 max. So my plane actually 435 is my red line. The Cessna 172S, which runs an IO360, says, ooh, you better keep that to 500 max. So this is a Continental up here, and this is a Lycoming here. So a big difference. I say that's where I want to be, but that's pretty close to 435. So,
Yes.
And of course, remember, that depends on where your temperature probes are. Are they spark plug probes, or are they bayonet type that screw into the cylinder? Are they on the top or on the bottom? Are you guys lost over there? Huh?
What's the Q? The Q.
It's a model.
It's a model.
Oh.
Like the one at 172S.
Okay.
So,
What does Q stand for?
The year it's
Just the number.
manufactured.
That's just.
It's automatically.
it's first it starts out with like A, then B,
Well, I didn't know
Then
if, like,
C.
the IOs.
then D.
Skipped out.
I didn't know the Q had any significance.
Each letter is the next year. So 1978.
Sort
Q,
of.
kind of.
Yeah, it's
like
kind
the next
of.
model, basically.
It's the one
It's the next
after
one.
P.
Yeah, it's like years for cars, but it's not, because they'll do it right in a mid-year change or something. So.
You know, when they do the manual, they put that limit in, is that just on that, you think that's designed just for that one cylinder that they have the measurement on? And that will keep the other ones?
Yes, because they put it on the hottest cylinder, and so I said mine. It's the middle one. I think it's the right middle. So mine from the factory had been number 4. It's in part of the type certificate data sheet. You cannot change it. And so the 172S, that's a Lycoming 4-cylinder. That would be probably it was 1, 3, 2, probably the number 4. It's 3 or 4.
What they take that into account when they put that number?
Yes, they do.
You know?
They probably put all the probes on, fly it, and go, okay, that's the hottest, it's going right there. So yeah, you can't change it around. Let's see. Okay, then we have the EGT. Exhaust gas temp, or EGT. Okay, unlike CHT, EGT, it just is. It's almost an irrelevant number. And so, this way or that way? That way. This is the first EGT gauge ever made. They're put out there. Notice the numbers.
What numbers?
There's no numbers. And the guy who did that, oh, it even says that. The original Alcor EGT gauge provided no absolute temperature information. The same was true of early engine analyzers and even the original Insight Gammy. Why did they not give you numbers? Because it's not relevant and it's meaningless. Your exhaust, so I could have my 182 and she could have the exact same 182Q, that's the model number, same engine, one serial number apart, and where's your EGT? Oh, my EGT max is like 1475. Mine's only 1410. Well, how come you're running so much cooler? I better go see a mechanic. No, it's my probes could be 1/8 of an inch lower. That'll do it. So it's where you put the probe is going to give you this. So it's irrelevant. The only time exhaust gas temperature has any relevance at all is when it's called turbine inlet temp. So if you have a TIT for your turbocharger, that is a number that you have to pay attention to. It will be redlined, and it will have max numbers. Otherwise, EGT is just it's EGT. And so the way the original, and these are still out there. I just installed one, replaced one the other day. You have a white line and a yellow line. The yellow line, you can't see it. There's a little screw right here. It comes with a little screwdriver, and you can use your fingernail, and you can move that, and the yellow line goes back and forth. Put it wherever you want to. It's a reference line the pilot gets to set. Okay. Notice there's a little asterisk right here. That's a little asterisk. Bing. Okay. And right about there, there's a hole. It comes with a little tiny plastic screwdriver, and what you do is you take off, and you hit the lights. It's actually there. You can see it on my thing. Yeah, you can see it right there. A little hole right there, a little tiny hole. Okay, it comes with a little tiny plastic screwdriver. You go in there. So you go, lights are good. So you go, you take off, and you fly, and you establish yourself in a straight and level climb. Pull out the mixture, and as you pull the mixture, EGT is going to start going up and up and up. You pull, it's going to go up, 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 and then you keep pulling, it stops and goes the other way. So push it back in, and you find right there where it peaks out. Call that peak EGT because it peaked out. Follow? Peak EGT. And then, right when you're at peak EGT, with the little tiny screwdriver, a little tiny hole, and you rotate it until the white goes to the asterisk. That's peak. Now you know where peak is. You've just calibrated your gauge. Who cares what the number is? All you need to know is what peak is. Okay? So you go to peak. Then what's the yellow thing for? Well, each one of these is 25 degrees. So if you want to fly, because they would say you should always fly 50 to 75 degrees rich of peak. Follow? So now it's calibrated. So pilot takes off, they're flying, establish your cruise, gonna lean it out, pull back on the knob. It goes, EGT gets higher and higher and higher. EGT gets higher and higher and higher and higher and higher. It comes right here to the peak. Okay? And now you're supposed to push it back in and richen it. It goes back the other way. How far do you go?
75.
According to this, 75 degrees. We'll talk about why that maybe isn't the best idea. A lot of people do 50. It's even worse. It's worse, okay? Or some people like to fly lean of peak. You can do that in a fuel-injected engine. So you pull back the red knob. It gets leaner and leaner and leaner and leaner until we get to peak, which is pretty much about your best power. Okay? I keep pulling back. It goes the other way, just like rich. So once I get to peak, I can push it in and make it go this way, or pull it back and make it go this way. Because peak is peak. Anything you do off of that, it's going to go back the other way. So that's rich of peak or lean of peak. So whenever I talk about rich of peak or lean of peak, I'm strictly talking about what temperature gauge? EGT. Otherwise, I'd say rich of best power or lean of best power. Most of the time. Sometimes I screw up and I'll think, well, it's lean of the peak, best power. I'll try not to. Okay. So exhaust gas temp, EGT. It's usually measured, if you install these systems, they'll tell you to install them here. So measured, I shouldn't even write that. Well, I will. Measured between 2 to 4 inches after cylinder. I say that, but then I think about 2 to 4 inches after the cylinder. So instead of your exhaust pipe coming down, you get 2 to 4 inches, drill a hole, put the probe in. But yet, my plane from the factory, it was like 8 or it's way down there. So it's not always that way. Actual number is not relevant. The original one didn't even have it. Typical EGT is somewhere between like 1200 to 1700 degrees Fahrenheit. Said mine runs about 1410 max. Mixture, the red knob, will have, let's see what we can say, a direct effect on EGT and CHT. This is a hard one to explain. I'm gonna, because I don't buy into this quite. So, this statement: exhaust gas temp. Could have just wrote EGT, save time. See world, I won't. Can be thought of as how much heat energy. Thought of as how much heat energy is wasted out of the exhaust. So the problem with that statement, let's see, how can I make it true? Because if you're running really rich, what's your EGT going to be? High or low? It's going to be low. And so based on that, running really rich wastes less energy.
You're wasting fuel.
Wasting fuel.
Yeah, that all makes
That's
sense.
energy.
Yeah.
It's to a point.
Yeah, and so when I lean it out to best power, I am going to see my EGT peak out, which means I'm wasting the most energy.
In the form of heat, I guess.
And the form of heat. Yeah, it's like that's why I like scratch my head, going, this is kind of a, I don't know. Anybody got?
Why is it important to know that?
Yeah, why is it important to know that? You want to know what your EGT is representing and what you're doing.
I get that.
I look at it a little bit different on these charts I'm going to show you here in a second. Kind of go, oh, okay, now I can just correlate the two. Because EGT is a funny thing. So I'm not saying this is false. To a point, it's definitely true. Case in point, okay? Doing a run-up on the aircraft before takeoff. So I'm going to run it up to, I like to run mine to 1700 RPM. I turn off one magneto to see how it runs. What should I see?
Drop
Drop in RPM. You know what else I'm going to see? All 6 EGT are going to jump up instantly. I watch for that. I can hear the RPM on even. I guess I do glance at the RPM. It's right there, but I watch all the EGTs bump up. So
When
what?
you leave it?
Huh?
When you leave it?
Just do a mag check.
Oh.
Yeah, man.
When you do a mag check, all your EGTs are going to jump very quickly by about 25, 50 degrees, just that fast. So what happened? Why did it do that? I know something funny. She's.
I don't know. I'm trying to.
What's that? Is it your chips? It doesn't bother me. I didn't even notice it. I noticed all these guys
trying
to not put you on blast for that.
snickering. What are they laughing about? Give me a corn nut. What are they doing? No, I'm good. Oh, they're pieces? Oh, I love Snyder's Pieces.
Now you want to listen. Now I know what it is.
This segment has been brought to you by Snyder's Pieces. Which, are they the mustard, honey mustard ones?
Oh, heck.
Oh, dude. No, then I'll start coughing. I'll get the dust in my hands.
I'm blessed.
You guys calm yourself down over here. All right, so why do my EGTs... I was thinking, you know what, I'm going to talk to you guys, because you're going to have something. Why did the EGTs...
It's so weird that you over there.
I know.
Why do the EGTs jump up when I just turned off my mag?
Single flame front.
Single flame front. Single flame front. It's taking longer to burn because now it's a single flame front. So,
Burning out exhaust.
more heat energy is wasted out of the exhaust. That's fact. So I said it's not true. It's just you have to be careful how you think about it. Just because you're increasing EGT because you're increasing power doesn't necessarily mean that. So, all right. Power ratios. Let me see what do I got here for power ratios. So see the slide. All right, this is off an IO 550 Continental. Let's see power ratios. This is what I want.
So you're saying that but the EGTs are not at peak EGT, you're wasting energy?
What?
So you're saying if you're not at peak EGT, you're wasting energy?
I did not say that. That's where I said I have a kind of a little bit of problem because it's not necessarily true, but because the statement was think of EGT, the higher the EGT, the more energy you're wasting. I'm like, well, I don't quite buy into that because I could lower my
Well, I said
EGT by
the other way around.
bunching of fuel. So
Well, that's
now you're wasting
now
fuel.
you're wasting energy.
Yeah. So that's why I said I don't
So
buy
if
into
at
that.
peak EGT would be most efficient.
Yeah. Let's find out. That's what this is.
In the next episode.
Now we're going to know. Okay, let's take a look at this and digest this a little bit. So I wrote a bunch of notes here so we can follow along, and I made some notes. So up here, this line right here is my EGT. So what's right here at the red line?
Peak.
Peak EGT, okay? Right here is my cylinder head temp, average cylinder head temp for this particular engine. So right up here is about how much? We're going to go this way. It's about a little over 420. Where was red line for Continental? For my plane at least.
435.
435. About 10 degrees short of red line.
Yeah.
Makes me a little nervous. Where do your cylinder head temps run?
What do I normally run?
Yeah.
Like 390.
Okay, yeah.
Climb out.
On climb out? Yeah. Like I'll close my cowl flaps all the way. It'll be they'll be in the high 200s for my airplane, depending on the outside temp. But anyway, okay, that's a little risky right there. Okay, we have here is brake horsepower. Okay, that's how much horsepower the engine's producing. Got it? And right here is brake specific fuel consumption, BSFC, brake specific fuel consumption. It is kind of like it's fuel efficiency,
Yeah.
right? So it's how much horsepower you're getting per for fuel consumption. So I got my green line. Now we want to go to blue line. Blue line is best power. Blue line equals best power. All right, so let's take a look at our blue line. Best power. I think that's a lie.
I thought it would be.
Oh, no, it's not. Right here. Brake horsepower. Right there. Peaked out right about there, didn't it? Okay, so that's my best power. What does that do for my EGT? Where's my EGT? Well, here's peak EGT. Is it peak EGT?
No.
It is not. So each one of these lines represents 90, 95, 100. Each one of these is 5 degrees. So here's peak EGT, right there. Okay, follow with me on peak EGT? All right, and so if I'm running peak EGT, how's my cylinder head temp running?
Pretty low.
Yeah, that's right, that's under 420. Seems pretty high. How about my brake specific fuel, my brake horsepower? How am I doing? Dropped a little bit. This would be the horsepower over here, so 240, 250 looks like max. So this is 250. I've lost about 10 horsepower by running at peak. Got that?
Yeah.
Okay, how's my brake specific fuel consumption?
That's pretty low.
Pretty low, okay. Let's see, brake specific fuel consumption pounds per brake horsepower per hour. So the lower it is, the better it is. So at peak, we're looking pretty good, all right? A lot of folks like to run 50 degrees rich of peak. So we pull out the red knob until it peaks out, and then push it back in 50 to 75. Well, that would be 5, 10, 15.
14, 50 on the right hand side of that chart.
I was looking down here. Fuel. Oh, it's fuel flow. That doesn't count. Yeah, I need degrees. Sorry, that's up here. So,
15 to 14.
so that would be from 15 right here. So it's 15, 25. So it's 20, 50 be right here, right about in the middle here. So that would put us right about here on the blue line. Blue line, best power. That's 75 to 100%. So, like I said, people like to run 50%. Or 50 degrees. 50 degrees rich of peak will put me about there where that dot is. That puts us right about max CHT and internal cylinder pressure. Oh, that's not very good, is it?
Is that why you said 50 is worse?
50 is worse. So back here at peak, where's peak? Well, the valves are hot, but cylinder temps are nice. Horsepower is good. Fuel consumption is good. All right, now 50 degrees rich of peak. Put you right here. Ugh. Yeah, good horsepower. All right, so then my red line or blue line, that's my best power. So EGTs have gone down. So we're losing less heat's going out the exhaust and more staying in the engine. May sound true? Sounds true. Cylinder head temp? This is still pretty freaking warm. Horsepower, all the way up there. Fuel consumption?
Pretty high.
Pretty dang high. And if we looked at a chart for our airspeed, you wouldn't see a whole lot of difference between the two. All right, now let's look at, before we go, our green line. Green being, green. So best economy, 30 to 7 degrees lean of peak. So lean of peak, EGTs are good. Cylinder head temp is fantastic. We've lost a lot of horsepower, but we're sipping fuel.
Want to use that when you're just like cruising?
Yeah.
How
Hell
different?
yeah.
And how different would be that green line versus red line with the fuel economy there?
Fuel economy, 85 pounds per hour versus 95, so 10 pounds per hour.
Yeah, that adds up.
That's like a gallon, 1.2 over 3.
Yeah. All right, I shall see you tomorrow.